I want to show you how you can do a hypothesis test with two proportions. So you can see here I have some weather data from 1980 and 1998. This is actually for Wasilla, Alaska, and it's for the month of October, and I'm looking to see if I can show that there is a difference in the proportion of days below freezing. So what I'm going to first do is I have to find my X bars. So what I'm going to do is I'm going to highlight all of this because I want to keep the data together. What I'm going to do is I'm going to custom sort, and I'm going to sort by 1980 smallest to largest. So then there were, well, there were no days under freezing. So let's pick a different day. I was going to do that, but that doesn't make any sense for this. I haven't really looked at my data. So I want to do days above 40. So days, I'll do days under 40. So days under 40, there were 7 out of 31. And then I'm going to do the same. I'm going to sort this again, custom sort. But now I'm going to sort by 1998 so I can look at that one. And the days under 40, oh, there were 7. So, well, this isn't going to do very good here. And this is part of real data, is I'm looking at this and going, okay, well, that didn't work, so let's try something else. Let's do days under 50. Well, let's do days 50 or above. Let's change this up the way. So if I do days 50 or above, this is now 4. And let's go back and let's sort these again. Okay, days above 50, that's a significant change. Okay, and that's 12. Okay, so I want to prove that there's a difference in the proportion of days above 50 between these 2 years. This isn't probably the test I would run on this. I actually have 3 years. I'd rather do an ANOVA or something like that, but this is to show you how it works. I'm not saying that this is probably the best test for this particular data set. This is just the data set I've been working with, and I'm doing this test, but you know, this probably isn't the best option. I'm going to go on here, and I'm going to go to Stats. I'm going to go over to Tests, and I'm going to go to Two Proportion Z-Test. And so 12 out of 31 and 4 out of 31. And I'm going to actually do not equals this time. Enter. Calculate. So I get 2.23. My p-value is 0.02. So at 5%, I would reject this and say that I do see a difference between the 2 years. And if I looked up my test statistic, and of course I could do that right here. I could go here and I could go second vars for my distribution. Please, come on. Inverse, and then I'd want, oh my gosh, 0.025 because I want half of my 0.05, right? And so you can see negative 0.96, which if I go back up here, you can see that that z-score, positive, negative, I'm proving either side, was well above that, which leads to my reject conclusion, as well as the p-value they gave us. Now you could, of course, do this by hand with your formula. If you want, you can also use StatCrunch, but the TI works really nice and quick to get a result. You could also get a confidence interval if you wanted, doing the same way. If I go to second stat, just go to stat, and then go down here, but I want two proportion interval. And again, to make this match, I would do a 90% interval. Nope. Actually, I did a two-sided, right? So 95%. And so then there would be my interval, and you can see it's all above 0, which tells me there is a difference. So this gives you some idea of how you can do this and the steps you'd want to take to do this. The big thing, obviously, is once you decide it, you're going to want to use your data to find your x1 and n1 and x2 and n2. N1 and N2 do not need to equal each other. It will work even if they don't. In this case, they did because October doesn't change how many days it has per year. But depending on what data you collect, like if you have men and women, you might have more of one or the other, and it will still work if you decide this is the test you want to run.